Okay, for 49, they want us to factor the polynomials, so it's x squared minus 64. So we want to just do quick checks to see if they're special polynomials, right? Because that saves us a lot of time. So I could look here and I see that this is a perfect square and this is a perfect square, right? This is x and this is 8, right? And they're subtracting them, right? So it becomes a difference of squares. So it factors to x plus 8 times x minus 8. And that's what makes the middle term go away. For b, I have y squared minus 6y plus 9. Okay, so this is a perfect square, y. This is a perfect square, 9, which is 3, right? So if I can multiply those two and get 3y, and that is half of the middle term, which it is. 3y is half of 6y. Then this is a perfect square trinomial, and it factors to the y, the 3, and then the sign that the middle term has, this minus, right? That minus. So y minus 3, and then let me erase that little arrow because I need that space there. Y minus 3 squared, right? It's y minus 3 times y minus 3. It's a perfect square trinomial. Okay, let's go on. Let's make some space. So c is 4x squared plus 4x plus 1. Again, I'm only looking for special cases because it saves time. If you didn't and you just went and factored this, normally, you'll get the right answer. But knowing the special cases saves time. So let's do a quick check. This is a perfect square, 2x. This is a perfect square, 1. If I multiply 2x and 1, I get 2x. And that is half the middle term, and the middle term has a plus. So this factors to 2x, and then the 1, and then the sign of the middle term, plus 1 squared, right? And d, let's look at d, 5x squared minus 45. Okay, one thing that jumps right out at me here is that there's a GCF here. They both share a common factor of 5. So I'm going to pull out that 5, and I get x squared minus 9. Now, many people make the mistake and say, okay, I'm done. I factored. I pulled out the GCF. I'm done. But you have to look if anything else can be factored. Now let's take a look at this. This x squared is a perfect square. This 9 is a perfect square, 3. And we're subtracting, right? So that's a difference of squares. So the 5 is still there, right? We're multiplying by 5. But this is a difference of squares, and it factors to x plus 3 times x minus 3.